More on Taylor series. Recall that the function, if possible, can be represented as an infinite series. The n derivative evaluated at x equals a over n factorial times x minus a to the n. For example, write the Taylor series for f of x equals x squared plus x minus 1, center at a equals 3. We would need to find the derivatives of f to find the Taylor series. The first derivative is 2x plus 1. The second derivative is 2. The third derivative is 0. The fourth derivative is 0, and therefore all of the derivative after is going to be 0. We then evaluate these derivatives at the center, x equals a equals 3. f of 3 is 3 squared plus 3 minus 1. We simplify into 11. F prime of 3 is 2 times 3 plus 1, which is 7. F double prime of 3 is constant, 2. F triple prime of 3 is 0. And all of the derivatives after evaluate x equals 3 is 0. The coefficients of the Taylor series is the nth derivative evaluated at x equals a over n factorial. We evaluate these derivatives already. We just need to divide it by n factorial. C sub 0 is 11. C sub 1 is 7 over 1 factorial. C sub 2 is 2 over 2 factorial. And C sub 3 is 0 over 3 factorials, and so on. We then use these coefficients along with the factor x minus a to the n to write the series. 11 plus 7x minus 3 plus 1 times x minus 3 squared plus 0 times x minus 3 cubed, and so on. We can simplify this to end up with x squared plus x minus 1, but the answer is 11 plus 7x minus 3 plus x minus 3 squared because we want the series center around a equals 3. Note that the Taylor series is supposed to be an infinite series, but if the function that we start out with is a finite polynomial of degree n, then the Taylor series is going to be a finite polynomial degree n as well. Another example, find the Taylor polynomial t sub 4 center at a equals 3 for f of x equal to the square root of x plus 1. That is, we're going to find the fourth degree Taylor polynomial around a equals 3 because we want to use it to estimate the value for the function f around x equals 3. The Taylor series is c sub n x minus a to the n, where c sub n is the n derivative evaluated at x equals a over n factorial. The first derivative is 1 over 2 the square root of x plus 1, which is 1 over 2 x plus 1 to the minus 1 half power. The second derivative is minus 1 over 4 x plus 1 to the negative 3 over 2. The third derivative is 3 over 8 x plus 1 to the power minus 5 over 2, and we keep taking derivatives successively. We only need the fourth derivative because we're looking for the fourth degree Taylor polynomial. We then evaluate these derivatives at a equals 3. F of 3 is the square root of 4, which is 2. F prime of 3 is 1 over 2 root 4, which is 1 over 4. F double prime of 3 is minus 1 over 32. The third derivative evaluated at x equals 3 is 3 over 256, and the fourth derivative evaluated at x equals 3 is minus 15 over 2048. We're going to use this coefficient along with the factor x minus a to the n to write the Taylor polynomial. 2 plus 1 over 4 over 1 factorial times x minus 3 plus negative 1 over 32 over 2 factorial x minus 3 squared plus 3 over 256 over 3 factorial times x minus 3 cubed plus minus 15 over 2048 divided by 4 factorial times x minus 3 to the fourth. Simplifying this, we have 2 plus 1 over 4 x minus 3 minus 1 over 64 times x minus 3 squared plus 1 over 512, and so on. This is the fourth degree Taylor polynomial centered at a equals 3 for f of x equal to the square root of x plus 1. Observe that one is a radical function, but the other is a polynomial.